Okay, so today's lesson is going to be on powers and exponents. Powers and exponents. And so to talk about this, we have to kind of just clarify and talk about what exactly powers are, how they relate to exponents, etc., etc. So normally, like when we're doing multiplication, when we're just doing multiplication, we might get something like, 3 times 2, and we know that equals 6. Every now and then, though, we get a special type of multiplication where we're multiplying a number by itself, right? I have 3 times 3 here. It's a number being multiplied by itself. What we do is we might show this by saying something like this: 3 squared. Right? We call this squaring. Squared. It has that 2 in the power there. And so we call that 2. We might also call it the second power. Second power. And the reason we call this squaring is imagine we had a square tile. And it looked like this, like the floor tiles that make up our carpet. The carpet's actually a bunch of little tiles. If you look closely, you can see that. And imagine they were 3 feet on each side. And I was trying to find the area. Well, the area is length times width. And the length is 3. The width is 3. So it's 3 times 3, or 3 squared. It makes a square. Okay? Otherwise, we'd say that would be 9 feet squared. Another power that we have is if we multiply it by itself 3 times, like this. We'll put a little 3 up there, and we call this cubed. Cubed, or we also call it the third power. And why do we call this cubed? Well, imagine our square from before. But this time, instead of just a flat square, it's a box or a cube, like this. In this case, we would say the area, or in this case, the volume. My mistake. The volume is length, width times height. 3 times 3 times 3. 3 cubed, or 27 feet cubed. Okay, so that's why we have special names for those. So that's anything to the second power becomes squared because it makes a square. Anything to the third power becomes a cube because it makes a cube. After that, if I do 3 times 3 times 3 times 3, that's 3 to the 4th power. That kind of transcends 3-dimensional space. So we don't really have a name for that, so we just start calling it 4th power. And you can imagine from there 5th power, 6th power, etc. Right? And we do all of this, but really when we're talking about algebra, what we care about are variables. So I'm going to go back to one of the problems we did on the pre-assessment. It looked something like this. Right? It was m to the 7th times m to the 6th. Okay? It was something like that. I may have changed the numbers ever so slightly, but that was our problem. And so what is going on here? Well, let's look at m to the 7th real fast. What does it mean for it to have that 7 up there? Well, it says it's to the 7th power. That means it's being multiplied by itself 7 times. So that means it's going to look like this. It means m times m, 3 of them, 4 of them, 5 of them, 6 of them, 7 of them. So m to the 7th is all of this right here. 1, 2, 3, 4, 5, 6, 7. That's what that means. Okay? This multiplication sign I'll make really big right here. And then m to the 6th is going to be 6 of them. 1, 2, 3, 4, 5, 6 times a lady. All right. I'll do that in green. So I have all of these m's here being multiplied by each other. Well, and you can see when I have 3 3s, that's 3 to the 3rd. 4 of them, 3 to the 4th. How many do I have here? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'd say that this is m to the 13th power. Right? That's my way of simplifying it because I have 13 m's. Oh no, it just appears to have paused. Let's see if I can unpause it. Let me pause this real fast.